In this episode of KubeFM, I got a chance to speak to Stephan Schwarz, who's a DevOps and infrastructure engineer working on Kubernetes platforms in production environments. Stephan shares his approach to performance testing Kubernetes workloads, starting with defining what performance really means, and then moving into resource limits, HPA tuning, and system-wide bottlenecks. Stephan and I discussed how to incrementally break and measure pod behavior under load, why shared components like ingress controllers and monitoring stacks often skew test results, and how tracing tools like OpenTelemetry help isolate slow services in production. Stephan explains why disabling autoscaling and making one change at a time is essential to understanding real application limits. He also covers client-side bottlenecks in load testing setups, such as file descriptor limits and environment misconfigurations. If you're tasked with benchmarking or hardening Kubernetes environments, this episode with Stephan offers clear, experience-based strategies that are definitely worth hearing. This episode of KubeFM is sponsored by LearnK8s. Since 2017, LearnK8s has been training Kubernetes engineers all over the world. Courses are instructor-led, 60% practical, and 40% theoretical, and they are taught in person and online to groups as well as individuals. Students have access to course materials for the rest of their lives so they can stay fresh. For more information, check out learnk8s.io. Now, let's get into the episode. Well, Stephan, welcome to KubeFM. To get started, can you just give me some more information about 3 emerging Kubernetes tools that you're keeping an eye on?
Sure, Bart. Thanks for having me. So to be honest, I have 2 categories of applications or tools. The first category, these are 2 tools. That's Crow, K-R-O, still very young, and the other thing is maybe not so emerging, not so young, but it's Crossplane version 2, and I think those 2 are the ones that I really will keep an eye on, because I think they really could help doing platform engineering and running platforms, developing platforms much more easy. And the second category, with the third tool, then would be Talos Linux. It's not really emerging. I think it's just new for me, right? So I really appreciate that you have this Linux host for Kubernetes, and you have it like in a not so old way, but more in a declarative configuration and atomic updates and all this stuff. That's great.
And for people that may not be familiar with KRO, could you explain a little bit more about what it is and how you're using it?
I'm not using it at all. It's just that I want to get into it. It looks promising. Like you have the abstraction of the API of the Kubernetes internals if you want, right? So you can define your own API, and then you have your object, whatever it is. And inside of it, then you have the Crow operator that is doing the things, the heavy work for you.
And Stephan, for people who don't know you, can you just give us some more background information about where you work and what you do?
Yeah, I'm the title is called DevOps engineer at iits-consulting. It's a consulting agency and service provider located in Germany. And we're doing projects around software, cloud, and DevOps and AI. As I said, my title is DevOps engineer, but it's more like something has to be there when people ask you. It's I have been a cloud engineer, I've been platform engineer. I consider myself as the infrastructure guy. That's probably the most accurate thing, because everything else I think is more like, okay, which kind of perspective do you take, right? Maybe people fight me for that, but that's how I think.
Okay. So when you're not fighting people, but thinking about, you mentioned some of those different titles. We think about DevOps, we think about cloud, we think about platform engineering. But how did you get into cloud native? Tell me about that process.
Yeah, I was. I started my career as a system engineer, very classically, and then I think 2016, I got into cloud engineering, starting the first projects on AWS. And then I was very fresh in cloud engineering, and then someone stood at my desk and said, okay, we need to do all this container stuff, and of course we need something which does the orchestration. Hey, let's give a shot to Kubernetes, and could you take a look into that? Then I set up a POC with, I think it was Kubernetes the hard way, and later I was with kops. Kops that templates the Terraform code, and then because with the Terraform, those errors that you do when you're new to something, and then we did that, and I actually discovered it's a whole universe that is going on there with Kubernetes and the stuff, and then I was sucked into there, and I'm still with that, and I'm very happy there.
And this whole universe that you mentioned, and in the beginning as well with, the tools that are coming out, how do you stay updated with the Kubernetes and the cloud native ecosystem, all the changes that are going on constantly?
Yeah, first of all, I don't have the feeling that I stay updated. It's more like I'm running behind everybody, but I think that's just everyone has that feeling sometimes. And so what I do is I have a subscription to Medium, and I also read when I have time. But I also consume some YouTube channels like KubeFM, of course, and Victor's DevOps Toolkit, and some others. But the most thing that really gives me the most is talking to other people, because you only get to know in these videos and these besides KubeFM, you only get what happened fine, but I'm more interested in where did the shit hit the fan. Am I allowed to say that in your podcast?
Yes, you are. Where did the shit hit the fan?
Because then you really get the experiences that people have, and really what to not do, and you won't find this in any box or something. So this is what I'm more interested in, and I try to keep contact to colleagues I work with and have worked with, because that's a really valuable resource. So people.
Great points. And I definitely agree that there's, at least in my own experience, talking about when things didn't go wrong rather than just constantly pumping, success stories, which it's nice to share success stories, but I think in general, most of us learn the most when something breaks, when something doesn't go the way that we expected, and how we had to troubleshoot, and based on the options that were available to us. If you could go back in time and share one career tip with your younger self, what would it be?
That's a hard question, to be honest. I think maybe that I'm paid to get the problem solved, and not that I get it solved alone all by myself. I think this is the thing, the career tip, because this is a lesson. It really took some time in the beginning because I tried to do it all by myself, and you're completely lost if you do that.
Very, very good. Don't suffer in silence. Yeah, I think that's a good lesson. Now, to what we're going to be focusing on today, we're going to be looking at, the topics that you mentioned in an article that you wrote titled Performance Testing Kubernetes Workloads. So we're going to go into this a little bit further. Now, Stephan, many DevOps engineers or platform engineers find themselves suddenly tasked with performance testing Kubernetes workloads without a lot of guidance. Could you share what sparked your interest in this topic?
Yeah, it was exactly this. It was someone standing at my desk and asking, okay, we have this application, we need to do performance testing, can you help? And then, of course, I haven't done it before, but let's go into this. I think this was how I got into this, I was quite unprepared.
Okay. But before getting too much into the technical aspects of testing, you emphasize the importance of defining what performance actually means in your specific context. Why is this definition step so critical for Kubernetes workloads specifically?
Yeah, we started really quite headless, so we just made things, and then this is why I published the article on Medium also, because I wanted to share my experience, because I had the feeling that a lot of people are there and need to do things that they never do before. I mean, that's basically the job, DevOps engineer, platform engineering. We're doing things that not many have done before. So, and as we did it, we realized that we didn't have a clue what performance is. Like, of course, we had a clue that performance is the application is running smoothly, everything's quick and nice. But in the end, what really is better? Um, is it good that the application is quick, or do you prefer the answer? So if it takes longer in your application, is it okay if it just gives you the feedback that I can do that in a timely manner? Is this error and you can receive it quick? Is that okay? Is that a better performance than you wait half a second and then you get the answer that you wanted? So what is performance? And I discovered that in our heads there are different feelings of what performance should be or is. So you have to talk about this and maybe write it down what you feel, what your consensus of what is performance is. And also another example, how many parallel requests per second are considered to be good? Is it 100, 1,000, million? What do you expect and what are the requirements? What is your application doing and how many requests or how many loads do you expect to be there? You can always invest a fortune so that all humanity can use your service, but is that really your requirement? Yeah.
You outline several key questions that teams should ask before starting performance testing. Could you walk us through the most critical Kubernetes-specific questions?
Yeah, so I think the most critical thing is it's not a question, but what you may want to achieve with performance testing if you want to get to know your stuff, because in the beginning no one knows, right? You have this whatever you're creating an application, you are running it, and in a dev environment, but you don't know how to set your limits, resource limits. So in the end, the thing that you really should achieve by performance testing is get to know the thing that you're testing. And so to start with, maybe the most critical question should be, how much load is my pod serving before it breaks, and why does it break? This is, I think, the two most critical questions in the beginning. Besides deployments, replicas, and autoscaling, first thing is, how much does one pod accept?
So with that in mind, let's focus on pod performance first.
Yeah.
How do you determine the capacity of a single pod? And why is this baseline measurement so important in the Kubernetes context?
Yeah, by breaking it. You flood it with requests until it breaks. And believe me, you will break it. Or what shall I say? It's not so clear that you break it, but you have a station where you send requests and you expect a certain answer, right? And if that isn't in your parameters that you think are okay, maybe it's taking too long, or maybe you get errors or something, then it's considered to be broken. But that doesn't mean that your pod is broken. Maybe it's still working, but only your client is broken, or the network in between, or a load balancer thinks you are denial of servicing the thing. Could also be everything, right? So I would say start by deactivating or disabling as many dynamic stuff that you can. Kubernetes has a truckload of features for scaling, like replica sets with replicas, like vertical and horizontal pod autoscaling, node autoscaling, and whatnot, rescheduling on pods on bigger nodes and whatnot. Just try to disable all the dynamic effects and get to know when one single pod breaks. And very important, inform the rest of your department about what you are doing, because it will have side effects and that you maybe don't have thought of. That's yeah. And when you do that, I think it's also very important to document what you did. So I just document, we're starting with one pod, no autoscaling, and it has this of RAM and this of CPU for requests and for limit, and then test what happens. And if it breaks, then just, okay, document the time it breaks. And then think, okay, why did it break? Look at logs, look at metrics, and then from there, if you identified maybe the pod was out of memory killed, then okay, give it more memory, put it on other nodes, whatever. But just change one thing at a time. Very, very important, because, and also document again, we are now trying with this amount of RAM, this amount CPU cores, and try again, and you will break it again, and then these are really incremental steps. I don't know how to do this much more much more fast. Of course, you can use a vertical autoscaler for right sizing the pod, but then something happens that you really need to get the feeling for your thing. And I'm now just talking about a very, very simple application like a REST API or something with a database. It not a complete microservice application with, I don't know, hundreds of pods or something, different pods, but just a very simple application. So yeah, just one change at a time and document it. Very, very important. Yeah. And
I really like the point that you make about documentation, because it feels like, depending on the organization, documentation can be more or less appreciated or emphasized. And sometimes it can be a challenge that I feel that engineers might face about getting enough time to do documentation. Any tips or, advice you would give on that aspect particularly?
really, it doesn't matter how you document. It's just that you know what you did, because in the end you will be sitting there with a lot of numbers, and if you don't know what are there for, then I was there, didn't do that. It wasn't fun. So definitely, that's I lost a day for that. So do yourself a favor and document what you did and what the outcome was, so that you know, okay, we had better numbers where. So then you can go back to this, right? Yeah.
Now, Kubernetes deployments typically involve multiple components like ingress controllers and service meshes. How do these Kubernetes-specific components affect performance testing?
Yeah, like I or tease it, you don't simply test the thing you want to test. You always test the whole chain, like from the testing client or clients, the network, firewalls, routers, switches that are underlying. Also, even if it's in a cloud environment, there's already also hardware underneath, and also shared resources like ingress controllers, CNIs, CSIs, dependencies like outside of the Kubernetes cluster, like load balancers, databases, service meshes, really everything, right? So be aware of that.
Your article mentions client-side limitations in testing. What specific considerations should teams make when setting up clients to test Kubernetes workloads at scale?
Yeah, that's as I said, I went to performance testing quite unprepared, and the first thing I did was run the test from the local machine. Right, it's not a good idea, because you're running into stuff that the application that you want to performance test is prepared to serve a lot of requests, and also Kubernetes is prepared for that, and the Ingress controller is prepared for that. Network is prepared for that, but your client isn't. And even when what we then did is we used a SaaS offering which has a performance testing control plane, but it uses EC2 instances in your AWS account. So we set up another AWS account and tried from there. But the image that we used for this machine was limited, like the most standard Linux distributions are, so that number of open files were very low. So what we then need to do was use an image that was for performance testing, or adjust the number of open files by yourself.
I know you mentioned previously a bit about autoscaling, but to focus more specifically on horizontal pod autoscalers, which are a key Kubernetes feature, based on your experience, what are the best practices for configuring horizontal pod autoscalers for optimal performance?
This is not an easy answer to give because it depends so much on your case, right? For me, it was easy because it was a workload that I'm used to say find out by performance testing what is the fuel that your application consumes. Like there are applications, the higher the requests or stuff that you are doing, the higher the load, the higher the memory usage, or the higher the CPU usage. And for my side, it was in your case it may be a different metric. In my case, it was CPU. So CPU fuel workload. This is very easy. You can set it to I think we set the HPA to 50% utilization when we started, and later we got more pods because we got more traffic on that, and we then adjusted to 70 and later 80% because the more pods, the more is a percent, right? And so
You mentioned that scaling in Kubernetes takes some time. Could you elaborate on the performance implications of scaling latency and how to account for it?
yes. Don't consider me an expert on this topic because the world has moved on since I last used that. So when I started performance testing, it was just the legacy of the basic autoscaler that could scale on CPU and memory. There wasn't this custom stuff that is in Kubernetes for now. And, but scaling takes still time. There's a good documentation in the Kubernetes docs. So take a look at that, and really the reading is worth it because what we encountered was that we created a test that launched an increasing amount of users load testing the application. And what we then saw that if I'm not sure what the English word for this is, the increase of users, if it was too big, then you could see that the autoscaler, the horizontal pod autoscaler is scaling, but it was taking too much time to do so. Because if it once scaled, then you have a little bit of a delay until it scales again. And if in a larger environment where you maybe need to scale some nodes as well, this also will take a while until they are scaled and your cluster is bigger. So you should really keep that in mind. And what may be a good thing to test is if your pod or if your deployment can say serve 1,000 requests per second, maybe just hit it with 3,000 requests per second, and then measure the time it takes for Kubernetes to repair this. So then you can see, okay, is that okay for my SLA? Do I have the error budget for this? If it is down in such a case for say half an hour, 15 minutes, something like this, or is it not okay? Then you have to plan a little bit more, spare pods, right? And these are the things you have to consider. It's as I said, it's not an easy topic.
Beyond application pods, what other Kubernetes components should teams monitor during performance testing?
In the best world, everything, of course. It's because you're always testing the whole system, and with the whole system I mean the whole Kubernetes cluster, and of course also the cluster you run your load tests in, because when running a scaling deployment, then you will also want to scale your performance test client, right? So you're also testing the network, shared resources, and also the monitoring stack. So monitoring stack going up in flames because of a load test, because it got so many metrics, and the system scaled up, and the monitoring stack did not, and then it went up in flames. This is why I said you should inform the company or the people you're working with about shared resources, right? You should inform them that you're doing things.
For more advanced listeners, you briefly mentioned telemetry in your article. How does observability fit into Kubernetes performance testing specifically?
Yeah, I mean, telemetry is more of a specific tool to measure performance in a particular way. Like what I until now talked about metrics and performance testing with Gatling clients and whatnot is like doing load tests. But there are things, or there can be issues with the running production cluster and production environment where requests are slow and you can't really say, okay, it's slow. I'm running a load test then to see why it's slow. It's not working like this, and you can't do this in production while it's slow, or you don't want to do this. You can, of course, but you don't want this. So what you can do there is using tracing, like the open telemetry tracing. That's what I'm talking about. Just Google open telemetry, you'll find resources there. And you can implement those traces into your applications. What this helps you to do is you get an overview, and you can trace. That's that's why the name is traces. You can trace the requests on this on your services that are dependent on another, right? So the first service that gets the request then sends out a trace ID, and every other service that gets involved from this request, be it authentication service, be it, I don't know, an image service, be it a database, whatever, gets this trace ID, and so then this service or every service can then emit their traces. Like I ask the database, and they can emit this events to the central tracing service, so that you can then take a look at, okay, why does the request from this customer requesting, I don't know, this resource take so long while everything else is working fine. So this is like I hope I explained it good.
Works for me. Kubernetes environments often differ between deployment, staging, and production. How should teams account for these differences in the performance testing approach?
You can't really expect that if you tested your application in a dev environment or QA environment, this is that you're safe for prod. Nothing prepares you for prod, because prod is always different. Even if you are doing development processes and infrastructure as code and everything that the DevOps processes give you, you still have your users, and you don't have them in QA and dev, right? You don't have production in other environments than production. So what you can really do, or only do, with performance tests is try to test patterns. Like what happens if I have this while doing this? So maybe what is if 1,000 users are requesting my application while we are doing a backup or a rollover of something in the backend? This is something that you can test. Does it affect? Or what is the difference in throughput or in request response latency between or as delta between versions? This is something that you could test, but this doesn't really give you any real security for prod. You need to monitor still in prod and have metrics, of course. So does that make sense?
Yes. To wrap up, what final advice would you give to DevOps or platform engineers who are just getting started on their performance testing journey with Kubernetes workloads?
Yeah, I would say, I repeat myself, only one change at a time. Document what you did. Can be Git as well. That's also documented. Very fine. Yeah, stay calm and inform the rest of your organization what you are planning. And for cases, have some sweets around and coffee. That's yeah.
Maybe that goes first. The coffee and sweets.
Sorry.
Then all the other things fall into place. No, that's fine. No, that's fine.
Yeah, you're right.
But I'm glad you got
Yeah.
that out in the open. And another thing as well too, while we're talking about, DevOps versus platform engineering. One of the key things that was mentioned in KubeCon when I attended Platform Engineering Day and moderated a panel about it with some different folks from the ecosystem, one of the people that was on the panel heavily emphasized that some of the people that are doing best in platform engineering are people that come from a QA background. To what extent would you agree with that?
I'm not sure why. Can you give me a little bit more why? What was the argument for that? Why?
I think it was being mentioned that because it might seem that it's not a natural fit, that that precisely some of what you mentioned earlier, that testing can't be, that a lot of people might have the tendency to act like testing isn't necessary, or that it's just a pain, or that it's something, that hopefully will be taken care of by somebody else. And I don't want to have it be, one of my priorities. That people with the QA background obviously see that differently because it's, what they do.
Yeah, okay, then
by definition.
Mhm. Then I see.
No, yeah, go ahead.
Then I see why maybe the argument was put there, because then the value that having the background as a QA engineer brings is that you have the customer in mind, that you have use cases in mind. I think this is, but I think everyone else could also have the customer in mind. So you don't have to have a QA background for this, right? I think it's important to be interested and to take responsibility for the service and for availability and for performance for the customer. I think this is the baseline, and doesn't matter which background gives you that.
I think it's a great point. And this is something that was also mentioned in the conversation that we had at KubeCon, was how, for platform engineers to think of themselves as engineers that are building a product, and that they have customers who are developers that they're going to be serving. And like you said, you don't have to be a QA, but no matter what role you have, that is something you should probably be keeping in mind.
I think
what you are doing is to serve the needs of a customer.
I think what's important is, as you said, platform engineering. The most important thing for platform engineering role, I would say, perspective, is I would more describe it as a perspective, because as a platform engineer, you see the thing that you build as a product. You have to. If you don't, then it's not good. It won't be good.
Yeah, no, I think that's a very solid point. And I really like your approach to this, because it's very practical. It's not just, the theory tells us this, you're referring to things that you're doing in your day to day. In terms of communication side, that's also something that's often overlooked, the soft skill, but that is what enables the hard skills or the technical skills to come to life. In your experience, the human aspects of platform engineering, specifically this one of communication, any tips that you like to share about that?
Be curious and talk to many people. Don't be afraid to go to sales. People, don't be afraid to go to, I don't know, if you're an operations guy, go to developers and talk with them. They are people as well. And the good thing is, if they look strange to you, if they are like they are creepy, that's a good thing, because they are doing things different than you, and they know things you don't. This is, I think, I need to encourage myself. I'm also just a human, but I learned that you can really learn from anyone. So be curious, be open, be transparent. This really helps.
Agreed. I think what some people refer to as calling, having the beginner's mind, that there's always something to learn,
Yeah.
and carrying that openness with you, no matter what your experience is.
Of course. I mean, it feels good if you know what you're doing, right? For me, I'm more into the DevOps engineering and stuff, because I'm forced to keep a beginner's guide, because I'm always faced with something new, right? And this is something that is really challenging and really cool, because you keep on learning. And I know that the things that I'm doing today, I won't be doing in a year. I'm very sure about that. So this is keeps me young, I hope.
It's a good strategy. What's next for you, Stephan?
Yeah, I'm bringing Kubernetes to edge locations, at least I try. So this is something I'm playing around with. This is why I'm so interested in Talos at the moment. Yeah, bringing Kubernetes to locations which are not the cloud or the data center, but yeah, more like stores or something.
Very cool. Sounds good. And if people want to get in touch with you, what's the best way to do that?
Direct message via LinkedIn would be cool.
It worked for me. I can speak to that firsthand experience. That being said, really nice having you with us on the podcast, and I hope our paths cross soon. Take care.
Thanks for having me. Bye.